right, my friends. We're going to get started here in just a couple minutes. Our wonderful, awesome colleague Yvette Lehman is here to help us out. Yvette, what are people looking to get themselves involved in here at 8:15 Eastern Time on the East Coast of North America and wherever you're coming to us from and at whatever time?
Hi, everybody. Welcome. If you're joining us for the first time tonight, welcome to the 2024 Make Math Moments Summit. We're thrilled to have such a huge community of educators. I was saying to Sue when we were chatting before, it's just inspiring to see various educators across North America and the world committing to professional learning on a weekend from your homes because you are, like us, dedicated to improving math experiences for students in classrooms. So we are thrilled to have you, and it's a privilege for me to welcome the host of this session, Sue Looney. Sue is an accomplished consultant. She has a doctorate in curriculum and instruction. She's also an author, and she's going to spend the next hour talking to us about why early math matters. So stick around. At the end, we'll have some information for you, as well as there is a door prize for this session. So stay with us until the very end. And for now, I will hand it over to Sue.
Excellent. Thank you so much, Yvette. I want to start by saying thank you to Kyle and John for inviting me to be here tonight. And a huge thank you to everyone who's taken time out on a Friday after work, whatever time of day it is, to be here. If you want to drop into the chat where you're coming from, I would love to see where everybody is. Wow, from the Philippines, amazing. Idaho, Florida, wonderful, awesome. We're gonna jump right in. So I'm going to go ahead and share my screen, but super excited to be here tonight. So let me just get my slides in slide mode and we'll get started. So we're here to talk about early childhood and specifically counting. And I wanted to start with this question here. If you could, and if you're interested, I invite you to drop into the chat. What did you count today? And how did you count that? And I'll just pause for a moment and we'll see what people were counting. But I have an idea that we probably can't get through a day without counting, right? We probably are always counting something: steps, stairs, time, handshakes, right? And even this dog here, not that the dog has language, but this mother dog is very aware of her whole litter being with her. So this idea of counting is very innate in all of us. And of course, as humans, we put language to that. So I wanted us to just stop and think about how critically important and how it's part of our everyday life. Oops. My job today is to convince you of three things. So when we're done today, hopefully I will have convinced you that early childhood is critically important. And maybe you already know that, but I'm going to give you some strong evidence to share about that idea. Also, we're going to do an exercise together and delve into this idea of the complexity of counting, and that has to be developed carefully over time. We're going to take a look at what some older students' work looks like if they have maybe not developed counting carefully, and then that you're positioned to change the game, so you'll be leaving with ready to use activities for your students in your schools. So I'm going to take you on a little journey to see how I sort of got here as someone that cares so much about early childhood. And this is one of my favorite pictures. This is me, and I had an opportunity to work in the city of Guayaquil in Ecuador. And the day before this, the students were seated in rows. None of the girls were participating. And I was able to get in there the next day and do some teaching. We're playing a game here called Factor Captor, and you can just see on their faces how excited they are. Since this trip, this school now has a STEM girls club that's been meeting for several years now. So I am truly passionate and really do believe that all students deserve this kind of an experience in mathematics. And I'm going to just take you on a little journey of how I got here, going back to the 90s. So this is me shortly after graduation. And I thought that I was going to be a lawyer. I was an English major. and I was on my way to thinking about law school, and I read a book. I don't know if anyone else has read this book, called Savage Inequalities by Jonathan Kozol. And there are some things that he said here that lit a fire that is still what drives me today. And it leads me into our topic for today, which is early childhood and counting. So I'm going to show you some quotes from the book, and I think you'll agree they're still relevant today. The citizens of the United States have become experts at blaming the victim. So we have a lot of talk in schools about fixing kids, right? Why can't these kids do this? And maybe we need to look at our resources or our teaching strategies, or something else might need to be what needs to be tweaked. But we spend a lot of time sorting our children, grouping our children, and trying to fix them. The ability to benefit from a good education is still a function of class privilege, highlighting how educational success remains closely tied to economic status. Poor kids are not typically lacking intelligence. The genius inside them is never given a chance to emerge. The immense resources which the nation does in fact possess go not to the child in the greatest need, but to the children of the highest bidder. And in public schooling, social policy has turned back almost 100 years. So Jonathan Kozol was sounding the alarms back in the 90s, and his book inspired me to jump head first into education. And I think we still see some of this today. We have what is often called an opportunity gap. And I know this is a lot of words on this one screen, but I felt like every single word here was important. So our opportunity gap tells us that we have unequal and inequitable distribution of resources and experiences on the basis of race, ethnicity, socioeconomics, English proficiency, disability, immigration, et cetera, et cetera. And all of this contributes to and perpetuates inequities for groups of young students. This from the National Library of Medicine in 2023. And so the opportunity gap that we have leads to an outcome gap. And maybe you feel a little bit like this man on the bridge, right? Like there's this gap and you're just like trying to pull that across, right? Like, how do we bridge the gap? And what do we do about that situation that we're in that just doesn't seem to have changed? And can we change the game? I absolutely believe we can. And I'm here to talk to you about how we begin to do that. We need to focus on counting in the early grades. And so here's why. We're going to take a look through the research. The first piece of research has started being mentioned quite a bit lately, which is really exciting to me because it comes from 2007, but I've heard this mentioned a lot lately. And like I said, I am thrilled about it gaining traction again. But this study was done, and the researchers looked at what was the greatest predictor of success in school, not in mathematics, in all schools. So was it reading? Was it attention? Was it social emotional? And it turned out to be early math skill. And it was such a surprising result that this study's been replicated several times, and every time mathematics comes out on top as the skill that most greatly correlates with later success in school. So early mathematics, so critical. We go on and we hear from the National Research Council in their book in 2009 that for most, the potential to learn mathematics in the early years of school is not currently realized. Those who start out behind in math will remain so. This part of the quote keeps me up at night sometimes, because this is not what we want at all as educators. But there's hope here. It says, without extensive, high quality early math instruction. So that's what we're talking about tonight. So unless we start early, we are at risk of kids that start out behind remaining so. Young learners' future understanding of mathematics requires an early foundation based in high quality, challenging, and accessible mathematics. So here we have NCTM coming in and sort of sounding that same alarm. I don't know how I wrote on my screen. We've got a nice blue smear there. I don't know, Yvette, if you can. Thank you. And then we talk about our early childhood educators. So this quote here from Ed Week in 2017, early childhood educators those that are expected to impart those early math skills are often left out of professional development. And so maybe early childhood educators aren't left out, but is it specialized for you? And I just know so often I'll walk into a school and I'll know that they have preschool teachers there, and I'll say, can I meet with preschool too? And the answer will be, oh, you can do that? And I say, absolutely. So we want to make sure that we elevate early childhood educators and include them and bring them to the table. And this is a long quote here from the National Library of Medicine of telling us that basically we don't have federally mandated preschools. And so without that, we have unequal access. And so that inequity is continuing to be felt by most children from marginalized populations. And so what is the conclusion from all of this? Well, I wrote a blog a while ago about a gatekeeper, and we hear often about algebra being a gatekeeper. We hear about fractional understanding, but I think it happens much sooner. I think all of this research points to the idea that we need to intervene and work with children starting really early. If we don't, what we do is we build this house of cards. So this is a really pretty house. It's kind of cute, right? So maybe kids can get answers. Maybe kids know how to do things, quote unquote. But if we don't have a strong foundation, it for sure eventually comes crumbling down. So that's going to bring me to the second part where we're going to talk about that complexity of counting. And I'm going to have you do an exercise with me. So I'm going to stop the share. And I wonder if I can figure out that blue, the blue mark. Yeah, from Erin, the house of cards starts to fall in middle school 100%. So we are going to do an activity where I'm going to ask you to imagine that you're a child learning to count. And you can't read, you can't write. You've got to take in all the information auditorily. You're somewhere between 2, 3, or 4 years old, or possibly you are a multilingual learner. So you're taking all this information in through your ears. And if you are inclined to do so, it works best if you will speak out loud to nobody if you're in front of a camera. But at least have that voice playing in your head to play along with me, okay? And so we're going to do an exercise, and then I'm going to ask you to reflect on it. And I'm going to go a little fast, so that is somewhat intentional. So here we go. Today, we are going to learn to count, and we are going to count just to this many. That's all we're going to count to. I'm going to say the words. I'm going to say them a few times, and then I'm going to ask you to say them back to me. And so our counting words are seize, nudge, drift, jingle, romp. I'm going to say it again. Seize, nudge, drift, jingle, romp. Let's try to say it together, either right on out loud or in your head. Seize, nudge, drift, jingle, romp. All right. And now I'm going to ask you to, I'm going to kind of nod my head, kind of say it without me. You bet. Your face is classic, right? Okay. I'm going to do something that might help a little bit. And I want you to notice, womp womp from Kelly. I want you to notice what I'm doing. Seize, nudge, drift, jingle, romp. So I just gave you a visual, and in that visual, you've got a little bit of an advantage because when I say romp and I go like this, you already own what that is. You already know, and you're like doing this translating thing, but you can imagine a child isn't. So I'm going to just show my fingers. The Zoom just asked me to confirm what language I'm speaking because it doesn't recognize our words. That is fantastic. Okay, I said it was English. So I'm going to show fingers. I'm going to say it again, and then let's see if you can say it along with me. Seize, nudge, drift, jingle, romp. Okay. I noticed some of you moving your head, right? What's that? Why is that helping, right? I noticed some of you were showing fingers, right? There's something about being active. This idea of how we acquire stable order, which is what this is, this order of numbers, movement, rhythm, visuals, all these things help. Okay, so now I'm going to ask you some questions. How much is this? And how do you know? Or do you not know? So many of you would say, I see it in the chat too, seize, nudge, drift, right? Like you don't just go, bam, drift. You have to have that running start, right? This one you might know automatically. How much is this? What word is this? All right. What is this, right? Maybe we've anchored to romp, right? Okay. And we know seize is where we start. But how about the number before? That's easy, right? It's just seize less than something. So what is seize less than jingle? Ooh. What is seize more than jingle? What if I asked you to count backwards from romp, right? I'm not sure I can. Do you want, some of you want to try? I see you trying, right? I'm not going to. Yeah. So this is just one exercise to help us be in the shoes of a young learner to appreciate. It's very complex. And for the most part, all I've dealt with so far is the words. We aren't really dealing with quantity. It's just that stable order. And we haven't dealt with symbols. But I'm going to share my screen again, and I'm going to give you some symbols. All right, so let's give that a go. All right. Here we go. Here are symbols. I actually went back in time and took this from some ancient civilizations, and many of them actually do stand for numbers. And there are the words. So maybe you were saying something different, or maybe you heard the word nudge, but you thought it was spelled differently. I don't know, but these are our symbols. So, I mean, it's only romp. It's not very many. We just need to know them. So you ready to play the game? What's that? Or this, or this, or this, or this. Who knows, right? Who knows? Really complex to coordinate all of those things. So I just wanted to pause here and take a moment and see if you want to share a little bit. How did that experience make you feel, putting you in the shoes of the learner to experience what it means to acquire the language of counting at a young age? So I'm just going to pause and see if anyone wants to share anything about how that experience made you feel before we go on. Overwhelmed, confused, overloaded. Now I understand. My brain hurt. I felt like giving up. Absolutely. New empathy. All of it. Perfect. Yes. So this activity hopefully will stay with you. And it's just, we're just building our case, and I'm getting into 4 routines that you're going to take away from today. But we need to, we're establishing that appreciation of how critically important it is. And we really have to develop it slowly and carefully over time. And when we meet new numbers, right, we all of a sudden meet fractions, or we meet millions, or we meet percentages. There's all kinds of weird language and things all over again. And we want kids counting with all kinds of numbers, actually. So I'm going to move from here into the practical part of the presentation tonight. And this is part 3. So 4 activities, and I've got some great video clips of some students. So this is where we're going to get into the things that you can take away that are tangible for classrooms. And I share a link at the end where you can download any of it, but much of it, you don't even need anything at all. So why do we count? Think about what you think children might say, or what would you say to that question? And we're going to watch a short video clip. I talked to lots of students about this, a range of students, and let's hear from them what they think about why we count.
Okay, hi, I'm here today with my friend. What's your name?
Travis.
And Travis, how old are you?
6.
Okay, Travis, why do we count?
Because
It's a hard question. Can you think of a reason for counting?
it'll help you.
It will help you. Okay, and when does counting help you?
When you're struggling on a math question,
Uh-huh. Like what?
like 2 plus 2.
Okay, and we could use counting. Can you show me how we would use counting there?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 16, 17, 18, 19, 20, 21,
Okay.
22, 23.
Nice. My friend, why do we count?
So you give me a better account so I can count better and do it so we can learn math better.
So we can learn math better. And how do we use counting in math?
We use our fingers and we use the number line
Okay,
so we can get the correct answer.
okay. Thank you. So this is Reed. Reed, how old are you?
7.
7. Okay, I have a question for you. Why do we count?
So you learn math?
So you learn math?
Yes, with that.
Why else might we need to learn math so that we could count? Why do we have to count?
I don't know.
Okay, thank you. Name again. Okay, so I am here today with my friend, and so your name is?
Arlen.
And Arlen, how old are you?
6.
Okay, so Arlen, my first question is, why do we count?
I don't know.
Can you think of like a reason, like what would life be like if we didn't count? Why is counting something that we do?
To do math.
To do math. Excellent, thank you.
So this is where we're headed. So kids I encourage you to try this out. They rarely say, so we have enough, so we can find out how many. They don't point to measurement. They say it's because we do math, because we get answers. So it's just fascinating. And we can bring really young learners into the equation of why we're learning to count. We can give them a purpose. So I'm going to say, never count out anything your students can count for you. So if you're getting markers or paper or chairs to sit around a table, do we even have chairs for all of us? That question requires a lot. So we're going to take a look at a 3.5-year-old, and then we're going to look at some counting that I did with some 10-year-olds and see where this comes into play, this idea of giving them a purpose. So we're going to take a look at Bennett, and he's doing something that I call the get me task. And Bennett, like I said, is 3.5 here.
And Bennett, we are going to do the get me task. Would you get a cup so that each of our friends at the table has a cup? How many cups are you going to get?
1,
Okay.
2, 3, 4, 5,
4. Can you give each of our friends a cup? Do they all have a cup?
Yeah.
All your friends have a cup?
No.
Oh,
1 more.
okay, one more. Can you take any extra cups off the table? Any of the extras that we don't need?
I did this.
And And you can put them on the chair over here. And now, does everybody have a cup?
Yeah.
Are you sure? Look at the table. Does everyone have a cup? All your friends?
Yeah.
They all have a cup?
Nope, one more.
Oh, one more. Okay. Nice job. And Bennett, can you tell me how many cups are at the table right now?
1, 2, now 3, 4.
How many cups are at the table, Bennett?
I'm gonna go potty.
Okay.
This one never fails to make me laugh. So Bennett has so much going on here in this task, and it's obviously very much contrived here. His working memory is phenomenal. He holds on to those numbers as he goes around the table, and he takes a second look, and he quickly sees we need one more. So just this simple task of, can you get me enough so everyone has one, is phenomenal. So we're just going to unpack that routine just a little bit more and pull it up to some older kids. So do we have enough of anything? Do we have enough markers for everybody to get 3? Now we can be into some multiplicative thinking, right? The do we have enough tasks requires us to, well, how many of us are there? Like, how many do we need? And then how many do I have? And how do those two amounts compare? Right? So there's a lot going on there, and we can pull it into measurement. How long will it take? How far did that go? How do we share things equally? So anytime that we can give kids a purpose and let them do the counting, that's the way to go, no matter how old of a student we're working with. When children don't trust the count and it hasn't been developed carefully, they develop unfinished or fragile learning, or sometimes I say they give us the illusion of learning. So I'm going to share some statements, and I want to see if this resonates with you. Students don't realize counting on will give the same answer as counting all, right? So we do these crazy things like we hit our head, and kids are all whacking themselves in the head to hold that number in there, right? But they'll do it, but they don't believe it because they don't trust the count. They have difficulty decomposing things into parts. So everything is a collection of ones, and they're counting by one. So the idea that 5 is also the same as 3 and 2 is very challenging for someone that isn't understanding quantity and trusting the count. Have difficulty understanding the inverse relationship of addition and subtraction. So again, we can get kids to memorize, let's fact families, and we'll stick them in a house with the roof on top or whatever we're doing. But do we understand the relational aspect of what's going on with a set of numbers? That might indicate an issue with counting. Students may skip count, but don't realize it gives the same answer as counting by ones. And I'm going to go into that one in a little bit more depth. And related, a student might lay out groups to show you multiplication, but really when they go to find out how many, what are they going to do? They're going to count each and every one because they still are fragile. They don't trust that count unless they do that thing of saying and touching every single object and saying each number. So this is a story. I know these are a lot of purple dots here, but I have a few pieces of student work to show you. So there's an array here that's 5 by 7. So we all know if it's 5 by 7, it's 35. So I was sitting with a 10-year-old fifth grader, and we were working on some foundational multiplication work. And I said, how many do we have here? So he counted them up, and he counted by ones, and he said, there's 35. And I said, great. And I wrote down 35. And I said, can you count them another way? And he says, sure. And he counts by 5s. And he's okay. And he does perfectly. 5, 10, 15, 20. So how many are there? And he says 35. And I write that down, and I say, can you count it another way? So he goes through and he counts by groups of 2, and he ends at 34 and has to add one more in, and he gets 35, and he go to write that down, and his face looks at me, and he literally drops his jaw, and he goes, it's always 35. So he had gotten to 5th grade, right? And we're working on all kinds of higher level mathematics, but he didn't make that connection from his skip counting to his counting by ones, that no matter how I count this collection, I am always going to hit 35. What's amazing about that story is when we fill in understanding in that way, these children never go back. Like, he knows that now. There was such a light bulb moment for him. So the idea of the get me task helps us count and with understanding. Here's another piece of work, just how it impacts place value. Sally counted the same array. It's 5 by 7. She says there are 35 dinosaurs. And I say, okay, well, 35. So you wrote a 3 and you wrote a 5. Tell me about that 3. Like, where do you show me? Where's the 3 in there and where's the 5? So she circles the 30 dinosaurs and she circles the 5 dinosaurs and she explains and she understands what's happening there, but not Jacob. Jacob tells me there's your 3 and there's your 5, right? So older kids have these disconnects later in time that might signal to us we actually need to turn our attention back on some of these counting activities. Our second one, so that was the get me tasks. The second one is recreate your hundreds chart. I am on a mission. I want to see hundreds charts transform, and here's why. So we're going to watch a video clip. This is from the Dream Network, which is a network about development and research in early math education out of Stanford University. And this is one of my very favorite clips of Anna. And so we're going to watch Anna, and then we're going to get back to that hundreds chart.
Please count as high as you can.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. What comes after 3? I know 4. 41, 42, 43, 44, 45, 46, 47, 48, 49, 50.
Yes. Can you count higher than 60?
51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79. What comes after 7?
8.
81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 93, 94, 95, 96, 97, 99, 99.
Let's come after 99.
I'm not sure yet. Maybe my mom.
100.
100.
Good job.
Yeah. Amazing, right? Anna stops at 39 and says, what comes after 3? Oh, I know, 4. And so she knows this pattern that repeats, and she's got the hands going, right? And she does this 39, 40, right? And so I think we need to reflect this in our hundreds chart. And so look at this, 30s hanging out here with the 20s, but it's not part of the 20s. And think of Anna right there. She went 29. So I want it to look like this. I want my 20s together, my 30s together, my 40s together. I want them all in a row. And I want that 0 through 9 pattern to be just going over and over again for kids to see. And what I've done here is I've color coded this. This is one of the resources that I share with you so that every decade looks a little different by color. We learn the name of it and we can really notice those patterns within the decades. I've had a lot of debate with people about the 0 here, and if you don't want the 0 there, it doesn't need to be there. I mean, certainly if I'm counting objects, I wouldn't start with 0, but if I'm measuring something, I do, and 0 is part of the pattern. So technically, this is not a 100s chart. It's a 0 to 99 chart. And I want to talk to you about an intervention I did with a first grade student. And then again, I'm going to show you some older kids' work that really changed the game. So this was the work that I received. I was working as a director of mathematics in a small town in Massachusetts and working with all the schools. And a first grade teacher brought this work to me. They had a student who had arrived in January and she had no records. And the teacher said, "Oh, Sue, I'm so glad you're at our school today. Check this out. I don't know what's going on." Right. And so understandably, there was some alarm, like, what is happening? There seems to be no rhyme or reason. And I said, "Okay, no problem. Let me sit down with this child." So I sat down and I had a chart like this that I'd cut it apart. So basically I had 100 tiles and I said, "Okay, let's build a hundreds chart. Let's just build it." I said, "Let's get our first numbers. Let's get out of the way, 1 through 9. So we found 1 through 9. And I said, "What comes next?" And she said, 10. And I said, "Great. Can you count more?" And she knew the teen numbers. I said, "Let's find all of those. Those are our teen numbers." And I said, "Those all start with a 1. What comes next?" She said, 20. And I said, "Okay, what do all the 20s start with?" She said, a 2. I said, "Perfect. Let's get all of those." And so we continued. Younger children, when you get to the 3s, I'll say, "What are those called?" And they don't say 30, they say the 3Ds, which is awesome because they're seeing a pattern. It's just unfortunately not our word in the English language. So we constructed the hundreds chart, and she filled one out. She did great. And then we went on break. And so I was nervous because I thought, does she own this, right? Is this fragile knowledge? And my gosh, now I'm not going to be able to see her for a couple of weeks. By the time we came back, it was January. Her teacher then sent me this. Now, also, she still has her 10s on the side. That's the chart the teacher gave her, but it's perfect. So again, like the story about the 5th grader counting the array of 35, one intervention. It took one exact right task, and the knowledge is filled in, and we're off and we're flying. So we're pointing out patterns. We're pointing out this is just how mathematics works. And we're having kids construct that, and then they own it. And so what a shame it would have been if this child had been labeled up one of our red kids, right? "Oh, here she's so low," right? "We better pull her out of math class." And really, I don't know what the misconception was exactly, but we did one activity and she was all set to go. Here's just some work from some older students. So this work comes from a while ago, but this was a surprise. So I have a 5th grader and a 6th grader. And when asked to fill this out, what comes after 100 was lost on them. So can you imagine what is happening in your mind mathematically if you're Ben and you're in grade 6 and you're learning about ratio and proportion, but you believe that after 100 comes 110, right? And so where is the 0 through 9 and the decades repeating? And so checking in with our older kids and giving them some of these simple tasks and looking for those patterns. So that's activity 2, the hundreds chart. And I want us all to make them like this. That's my mission, one of them. And just one more thing, if we see the patterns, I just have to say this. I have opinions about rounding numbers, but it is in our standards, and it's something that curriculum has us do with kids, and sometimes it does come in handy. But we teach kids these crazy rhymes. I don't know. Sometimes we have dances. Why does 5 go up? And something about 4 and hitting the floor. I don't know. But if we know, look at what happens if we actually get ourselves immersed in this repeating pattern of 0 through 9 instead of 1 through 0, right? The reformed hundreds chart I showed you is a 0 through 9 pattern. Look at what happens if I look at my 20s and I've just put a break in the middle there. There they are. It's a 0 through 9 pattern. The lower 5 numbers are 0 to 4, and the higher 5 numbers are 5 through 9. That's why those are rounded up, not because 5's like magically at the top of the hill and it's not going to start running down. It's because it's the upper half of the decade. The decade doesn't go 1 to 0, it goes 0 to 9. So these patterns matter very much, and they impact our older kids. The third activity I call Goldilocks math, and this is another one where I share a worksheet for it, but I don't think you really need to have it. I think the idea will make sense, but I do share that with you. So in the chat, I'll give myself a pause here. When is 6 too much, too little, or just right? And why are these kinds of questions important? So I invite you to give some ideas about 6 being too much, too little, or just right, just like Goldilocks. I'm going to go ahead and open up the chat. So I've got the comments here on rounding. I know that was pretty mind-blowing for me too when I learned all that about the 5. Too much to count on one hand when you're estimating, when counting fingers. 6 is just right when you want to make a hexagon. Ooh. How many fingers and toes on each appendage? 6 is too much if you're talking birthday cake. Too many pieces of pizza. There you go. You've got the idea. Awesome. It could be 1,000, right? It could be 1.25. It could be percent. It could be anything. When is blank too much, too little, or just right? I did make a worksheet, and I've got some sort of fake kid work in here. So if I give you the number and I fill in 3 and I have the child just illustrate, and then I can scribe their words, right? So 3 is too small of a number for potato chips in a bag. And I can just, if the child isn't able to write those words, they can illustrate it and tell us. It's just the right number for friends at my lunch table, and it's too big of a number of dogs to take on my walk. Okay. And we can do a variation on Goldilocks math. So I can give the scenario, and now you've got to fill in a reasonable number. I really love this switching it around. So blank is too small of a number for pages in a book. You get the idea, right? You can read on the slide. I could also have a bank of numbers. I could ask for, give me a range of numbers. There's a lot of ways to go here. So in giving you these 4 activities, I wanted to look at different kinds of things. So we had purpose, then we have pattern, and now we have magnitude. We have true number sense here. Like, what is the meaning of the numbers in context? And that's what Goldilocks math will do for you. So our last one, I saved this for last in case we ran out of time, because I think a lot of people are familiar with counting collections, but it is an awesome activity. And if we think back to the students that counted those dinosaurs wrong, they could really benefit from doing some counting of collections. And some of those bullet points that I gave you about kids not trusting the count, this would really help them. If it is new to you, I'm going to explain it to you. So children look at a collection and we think, how might students count these, and how might they organize their counting? And so we're going to think about that. And I found some really nice images just searching on the internet of some posters that teachers have made about counting collections. So basically, students go and get a collection of objects. They find out how many are there, and then they draw how they counted it. Ideally, they're doing it with a partner. So there's your built-in check. So if I let loose my whole class to count, and I don't know, let's say if they have one-to-one correspondence, I don't know if they can count in groups of. My way of managing if they're doing it correctly is that they're in partner pairs. So they count together, they count separately, they compare, and they have to agree. So that's meant to be a critical component of it. These teachers had some neat things, like the one on the left, they could record their voice. And on the right, this class brainstormed all kinds of things that they could count. So I love that. And then it's just time for counting collections. You visit the poster and you go find something to count. Everybody likes to count. I like to count. I think people enjoy it. This is a very typical example of what you might see. So there's a little box with frogs in it, and it's box 8. And this child knows something about place value. So they were grouping by tens. So they have 2 10s and 9 1s. Now, maybe they had a cup for those 10s where they put them all, the frogs in. I'm not sure, but their drawing shows us that they had 2 groups of 10 and 9 1s. And then they have the numbers to refer to on the bottom. Here's some more pictures. The one on the left is really typical of very young students. I did this routine recently in a preschool, and a lot of the preschoolers were tracing around it or as they removed the object. And that's fine. They're not really grouping yet. They're really just counting all. And so it's a record keeping thing. But you can see some other tools that are helpful here. I might put 10 frames on the recording sheet to encourage thinking in tens. I might have number paths out so that as students are counting, they can put one object on each number on a number path so that it's helping them recognize those numerals and sort of slow down that one-to-one correspondence, which can be tricky for kids. And here's some more pictures. So that picture on the right, that's a much older student with a whole lot more pom-poms. I love the picture also on the lower right. So there you see the kids, they've got their clipboard, they've got their whiteboards, and the teacher's listening in and looking in. So we want to give them some organizational tools too. And I like to give them choice for that. So they're just out, like grab a 10 frame if you'd like, grab cups if you'd like, and just sort of be a kid watcher, noticing what they're doing. There is a book all about this that's fantastic called Choral Counting and Counting Collections. Choral counting is another really favorite activity of mine, but we're not doing that one today. But also there's some free resources on a website that look like what you see on the left. There's an anecdotal record sheet that you can download, and then there's one of those forms that the kids could write on. So I do link you to that in the resources. So I'm just curious, I don't know if we have time. I think what I'll do is just open up for questions in a moment, but I'm just curious, how could these work for you? So you teach various different ages, various different needs of your students. And so I'm just, curious how you might use them, how you might modify them. These are the 4 tasks: get me tasks, giving a purpose of counting, don't count anything they can count. I want to see those hundreds charts changing up, Goldilocks math, and counting collections. Brianna, I see that your hand is raised, so I'm just gonna go through a couple things, and I'm gonna come back to you if that's okay. And Yvette, maybe we can let Brianna's microphone come on at the time. So my job today was to convince you of these 3 things. So I hope I did. That it's really important. We looked at all that research, and I do always like to come from that place when I'm making an argument for something. I read as much as I can. That counting is really complex. I maybe made you feel a little uncomfortable as we counted tonight so that we can appreciate what's involved there. And you were positioned to change the game, right? So we have really simple activities, but powerful. I talked to you about what they looked like when older kids, we went back in time and filled in learning. So I hope you believe. I hope that I've changed your mind. These are the materials for today. So you can take a screenshot of this. That is a QR code that'll work. Sometimes they get funky, so I also put the little URL on there. So that's how you can download the 0 through 99 chart, some of the research, and the Goldilocks math. I'll leave that up. I'll come back to that in a second. Oh, Yvette, you're going to drop that link in the chat, correct?
I just did, so it should be there in the chat for you as well.
Awesome.
And
Thank you.
Brianna, if you can try to unmute, I tried to give you that permission. If you can't, maybe let me know in the chat.
Okay, perfect.
Oh,
Can you hear me? Okay, perfect. I just didn't know if she was ready yet. So, the only question I have, is when you did that exercise where you cut up the hundreds chart, were you using a colored chart? And if not, or if so, did you recommend doing that? Because I'd like to use that exercise with some of my kiddos, but I don't know, like which one you recommend, I guess.
I did not use the colored chart, and I actually had plastic tiles. I don't know where I got them. I go back and forth. How old are your students? Brianna, is your microphone still able to be on? I go back and forth with that. Go ahead.
I think that I got unmuted and she got muted again. So I think it came too early.
Let's see if I can. There we go. Sorry, Brianna. Are you back? There you are.
On me, I didn't realize if I muted it wouldn't let me go back, so I just didn't want any background noise. My kiddos are 2nd grade.
I would not put the color coding on there. Yeah.
Okay.
I would have them looking for all the ones that start with a 1, all the ones that start with a 2. What do we call those? How many 10s are there? Having that place value conversation with them. Because instead we're going to look for the blues, we're going to look for the greens, we're going to look for the yellows. If you were working with a 4-year-old, and I have done this activity in preschools, then color might really come in handy for us.
Okay, perfect. Thank you.
Yeah.
Go ahead,
another
Michaela.
question?
Okay. I'm starting teaching in like a special ed class for kids with like mild intellectual disabilities in grade 4, 5, and 6 this week. And I was just thinking about some of these things and like what I don't know, I guess like teaching with those kids and like what I don't know. I was yeah, what kind
Yeah,
of
well,
things you would do. Yeah.
yeah, it's a great question. And of course, we don't know specifics about where they're at, but I think you could learn so much about them with county collections. You could
Yeah.
notice, like, do they group by tens? Because we certainly hope they do. Or are they like
Yeah.
1, 2, 3? So I think counting
And I know
collections.
sometimes the variation in where they're at academically in the class
So,
can be like vast as well. But I
yeah.
just thought that like they were probably more at the level of like early years math than where they are
Mhm.
actually in age wise. So
Yeah.
this stuff definitely all seems really helpful.
Awesome. Yeah, you could have them fill in a chart and see if they notice those patterns too.
Mhm.
Um, I think all of the activities make sense, but I would be particular. I think county collections is where I would begin. Of the 4 of them, I think you could get a lot of information about what's going on by observing that.
Yeah, thank you. I appreciate that.
You're welcome.
Matthew, go ahead.
Hi, could you comment on maybe, let's say, second grade and younger? How much time would you spend with direct instruction versus like learning through play or maybe free play?
Ooh, that is a big question. I, you know, I am a huge advocate for play and for exploration and for curiosity and encouraging that. I believe that we can mathematize the play. So I wouldn't mind a world in which if kids were working in centers or had a menu of options that they worked on, if one of them was just sort of open-ended, like freely explore X, I'm an advocate for choice. I can't put numbers on it because I know we're all held accountable to different expectations in our school, but play, I mean, what does Einstein say? It's the highest form of research. I'm actually giving a talk in Ecuador next week, and it's about innovation in mathematics, and I'll be talking about curiosity and play as the way to go, and that is innovative. So, but I understand that that it can't be all that, but I think math is playful, and we can put playful materials in front of kids, and then we can introduce a task in the language and elevate it. Does that help? Oh, you know what? Also, there's a great book by Michael Resnick out of MIT, and it's called Lifelong Kindergarten. And he has all kinds of research advocating for the benefits of play. There's something called some sort of a lab at MIT where all those MIT students go in and play and tinker and then create unbelievable things. So Michael Resnick, you can look for his research in that area too.
Thank you so
Okay.
much, Sue. I'm just,
All right.
looking at the chat as you're answering these questions, and I'm seeing nothing but just really positive takeaways from the session. And if, like me, my first reaction as I was engaging in this learning was, I can't wait to share this. I want to get on the phone with my kindergarten colleagues and tell them about my learning today. So the replay for this session will be available all weekend through your free ticket. But if you'd like to extend access to the replays or let a colleague know about these replays, you can also upgrade to an all access pass. That way those replays don't expire at the end of the weekend. There are over 40 sessions this weekend, so it may not be possible to hit all of them, but this would be professional learning at your fingertips beyond the weekend. And we are fortunate, we have a beautiful giveaway for this particular session. Cole is actually presenting this weekend around this resource, Daphne Draws Data. My personal opinion is that data is like the unsung hero of elementary mathematics, doesn't get the love that it deserves. And this is a beautiful, beautiful, accessible book, practical for your classroom, where they explore a variety of graphical representations. So I was watching the chat and I noticed that Fernanda had great involvement in the chat throughout the session. So Fernanda, I'd love to offer you this book. So if you want to just respond to any email you've received leading up to the summit from Make Math Moments, let them know that you attended Sue's session tonight and you are the winner of the door prize, and we will get this book in the mail for you. And anybody who is wondering, just a little housekeeping, you will be able to access a certificate for your participation in the learning this weekend. The goal is that they will be sent out by email by Monday afternoon. So keep an eye out for that. If you have any questions, again, if you respond to any email you've received from Make Math Moments, somebody will get back to you with any troubleshooting. And with that, it is now, 9:15, I think, almost 9:10 on the East Coast. And we just want to send, a huge thanks to Sue. Sue, this is my first time hearing you speak. And I am so grateful to have had this opportunity because it was eye-opening for me. I was texting John and Kyle. I was like, you're missing out. Sue is leading an incredible session. And I really felt that same enthusiasm through the chat with our participants here tonight. So from all of us, thank you, Sue, for your contributions to this community of just dedicated educators who want to do great things for kids. So thank you. Thank you to everybody who took time out of your evening. And I hope that we will see you in other sessions throughout the weekend.
Thanks, everybody. Have a great night.